So this is the spectrophotometry procedure video. First, we're going to talk about quantitative versus qualitative data. So when you do spectrophotometry, you're going to scan across all wavelengths first using a blank to find the maximum absorbance wavelength, which is also the lambda max. And you have to find a wavelength at which all the particles in a solution are visible. And the lambda max is found by finding the highest point along the spectrum's y-axis. And then as far as like contrasting the two types of data goes, quantitative data is going to be any like descriptive data that you would say using words. So like for example, it would be like the purity of a sample, and then qualitative data would be described using like numbers. So like the actual absorbance measure of a sample. The Beer-Lambert law states that the absorbance of a substance is proportional to the path length through which the sample travels and the concentration of the absorbing species. It can be summarized using the equation A equals epsilon Cl, where A is the absorbance, epsilon is the molar absorption coefficient, C is molar concentration, and L is the optical path length. It's important to zero the spectrophotometer before you start measuring absorbance because failing to do so results in incorrect readings of absorbance. Now we're going to go into the technique part of the presentation, which I animated. So first you're going to create your samples in the cuvettes. You're going to fill the sample to the top using a pipette. Only to the top line, not past it. And then you're going to take your sample to the spectrophotometer room along with your blank. And you're going to wipe the sides before you put it in the spectrophotometer. Okay? And then next, before you use your samples, you're going to use a blank to zero out the machine and find the best absorbance length. Following the following procedure, which you would also use to measure the absorbance of your samples. After you've wiped your cuvette, you're going to open up the spectrophotometer, and then you're going to place your cuvette into the spectrophotometer, and then you're going to close it, and then you're going to go to the computer, and there's a button that's going to say scan, and you're going to press that button. And then once you're done scanning, you're going to go back to the spectrophotometer, open it up, remove your sample, and then you're going to close it back, and it needs to be closed at all times if you're not using it to take a sample in or put a sample out. Once you've scanned your samples in the spectrophotometer, you're going to write down the absorbance measurements from the graph, and then you're going to plot your graph of absorbance versus concentration and get the R-square value, and these are all of our numbers, our data from the experiment. Thank you very much.